Okay, this video will be quite a bit shorter because as we mentioned when so we finished off right here with question number 40. This has covered like a whole year of chemistry, and then they kind of do the thing over again. So there's overlap on the first part quite a bit, but certainly we'll be adding some new things as well. So number 41 is a question about significant figures. There are still some of you who were missing that pretty easy point if you know your significant figure rules. So the page and section reference were there for you from the previous one. So if you want to turn things around on knowing when zeros are significant and when they aren't, this would be a good time. The density problem, again, make sure you know how to manipulate that. D equals M over V, and how to solve for all three of those quantities. This goes back to the shoe lab that we did, where you had to do the problems in every, you had to solve for the volume, you had to solve for the mass, you had to solve for the density. So make sure that you're comfortable with those equations. Number 43 is knowing the difference between observation and interpretation. Now, the in-class students are going to get a demonstration on this to see, what the difference is. It's kind of easier to see something or give examples. So you're going to watch the award-winning video posted in the classroom. I love this guy. But anyway, I think you'll get a kick out of it. It's a short video. It gives you examples and definitions of what is an observation and what is an interpretation. And if you watch that video and take notes on that, you're probably going to get number 43 right. Okay? And this one is challenging if you don't know the difference, but if you have examples, this one will come pretty easily. Number 44 is just talking about lab safety. You guys have worked in the lab for several years here at the high school. So I think this particular question should serve as sort of a common sense type of thing, where safety always comes first. All right, now number 45. Okay, number 45. This is a two-step mole wall conversion. Okay, and by the mole walls we have one that is the periodic table, one that has a wonderful picture of that of this guy right here, Amadeo Avogadro, and so that is the steps that you're going to be doing. So the big number, whenever you're talking about number of molecules, that's where that magic number 6.02 times 10 to the 23rd molecules equals 1 mole comes into play. So you can go ahead and add that right there, but that is the first conversion, which is an easy way. So you're going to be given like a lot of molecules, because that's just logical. They're really, really small, and there's always trillions and trillions of them. So, and then you go over here, and we're converting grams to moles using the periodic table. If it's just an atom, do that. Now, I'm not going to guarantee that the writers of this exam use our rule of going one place to the right. So if your answer is off by just a small amount, don't panic. That's probably just the atomic weight. But you can certainly use your periodic table to get the atomic weight. If it's a formula or a compound, use your circle square method and get that step right. I'm giving you that step because it's that number right there. This one is one of those where, yeah, you should get that right. Okay. Now, number 46, grab your yellow sheet. So organization is key to getting this test done efficiently. So you're going to have your yellow sheet, and you're going to write a binary ionic compound. You're going to put the formula for it, okay? Sodium chloride, and you'd write NaCl. Book reference would be 5.1 and 5.2 to review that, but using your yellow sheet to write chemical formulas, something we finished first semester up, and most of you did a real good job with that and have that skill down pretty well. And 47 is going to be using your yellow sheet to name a binary ionic compound. So you're going to be writing the name instead of the formula. Now, the cation often needs a Roman numeral, and your yellow sheet tells you which ones need Roman numerals. And remember, the Roman numeral is the charge of that first ion, which is the cation. So if it's Roman numeral 2, then the charge of that first one will be 2. And you might have to do some thinking to figure out what the charge of that one is. But this is yet another problem that you should get this one right, okay? Because you guys know how to do these things. So take your time and get that right. So number 48 is balancing a chemical equation. Again, there's some practice and book reference on section 6.3. I would consider this relatively simple, and I honestly, the ones I've corrected from the first test, I think everybody got that one right. So that's great because people wrote it down, they took time, and they made sure what was on the left was balanced with what was on the right. Okay? So you are now certified to take part 3 of the ACS final exam. Okay? So that will be tomorrow. Again, I will have talked to the whole class about people taking the ACT. Obviously, you will not be taking this test if you are taking the ACT, and your high score from the other 3 will plop right in on Tuesdays. Okay? And since I'm doing that for the people taking the ACT, that's why I'm making that offer for everybody. If you stumble on one of these 4 parts, your highest score will be used twice. And again, you're not going to see those scores until, like I said, I kind of grade it like on the last weekend, like it's one big final exam. All 4 of those scores will come and be posted probably this weekend sometime. Okay? So in about a week from today, roughly. All right. So anyway, make sure you watch the videos. Make sure you finish those molarity problems, which are due tomorrow at 9:10. And then I think things will go pretty well for you. And if you're taking the ACT test, the best of luck to you. Take care.